Hello and welcome to Video Notes 6.1, where we're going to talk about determining more linear models. This is picking up in Unit 6 here, where we left off in Unit 1, bookends, for talking about linear regression models here. So the first time we looked at this, we were looking at scatter plots, and we used our calculator to help us find linear models. Using the calculator function is called linreg, parentheses, a plus bx. I'm going to do a quick sort of show on your calculator once again to remind you where to find this and what information it provides. So let's go over to the calculator. Let's go ahead and remind ourselves of how to do a linear regression on the calculator. So the first thing you need is some lists. You need some things in list 1 and list 2. This is just, I don't know, some numbers that were already in here that I just am going to go with as my values. So if you want to put those in, you can, and pause and enter this data here. But you have to make sure, of course, that you have the same number of items in list 1 and list 2. Otherwise, things don't work out very well for you. And then what we're going to do is a quick reminder on how do you make a scatter plot. Well, you hit second and then hit stat plot. And then you're going to go to, let's just go to the first one here, make sure it's turned on. And it's this very first one right here, actually. It is not the last one. That's the normal probability plot. This is going to be the scatter plot here. And list 1, list 2, sure, we'll just say we'll call them at the explanatory response variables there, and hit zoom 9. And as we can see, it has made for us a little scatter plot of all of our data here. And now if I wanted to find the linear regression for that data, what I can do is I can hit stat. I can click over to calc. And I have a couple options for linreg. We always in this class are using number 8 because we use that form, a plus bx. So just hit the number 8 or scroll down. And it'll ask you what you want to be your X list, what'll be your Y list, frequency list. We don't have that, and we never will put anything in there. Remember, you can store your equation into your Y equals menu, and it'll graph it along with there if you want to. You don't have to, but if you're interested in that, a quick reminder, to do that, you're gonna go into vars, and then click over to Y vars, function, and then just choose one of the Y's there. I'll choose Y1 in this particular case. Not necessary though. It just means it'll store it for us, and then we can hit calculate. And then we have here Y equals A plus BX. That's the form we used. A is negative 7.1-ish, and B, my slope is about 0.67-ish. If yours gave you more information, good. If it didn't, then follow my steps here, because you're also supposed to get some more info from all. So let's see how to get that more information here, because I want that. It's actually going to give me my R value. So I'm going to go ahead and go here to my catalog. So I'm going to hit second, and then the number 0 you can see in blue is catalog. So we'll click on that. This is literally every single function and operator in the entire calculator. You can scroll through to find what we're looking for. It's not very helpful though, because there's a lot of things in here. Instead, we're going to go to the letter that it starts with. The thing we're looking for is called diagnostic. So I'm going to hit the letter D in green, which is right here with the X to the -1 matrix button. When I hit that, it's going to take me to the D's, and then I'm going to go ahead and arrow down until I find diagnostic. There we go, diagnostic on. Press enter. Press enter again. All right, let's do what I just did again with the linear regression number 8. I'm not going to store the equation this time. It's not worth it. I'm just going to hit calculate. And there we go. There's the more information I was looking for. So it has an R squared of about 0.92 and an R of about 0.96. So that is what we're looking for here. And that has all the information. So if you don't have the R squared and R show up for you, go back and watch my steps again. And then if you're still confused, make sure you ask questions in class. So that was the old way of doing things. Let's learn another method that we can do things that doesn't really require those menus of your calculator. Is completely reliant on 2 particular formulas here. We got that B, note that that's the same thing as slope, is equal to R times S sub Y over S sub X. In words, we would say that the slope is equal to the correlation coefficient times the ratio of our standard deviations for the Y and X values in our lists. The other formula over here is y bar is equal to a plus b times x bar, or in other words, the mean of y equals the intercept plus slope times the mean of x. So those bars are representing the means, the arithmetic means we've sort of talked about in the past here. Those two formulas there are going to help us out today. You don't have to memorize them. They are on your formula sheet. Let's go over to the formula sheet really quickly. So this is page 2, page 1, and we can see that right here we have these two things for our linear regression problems that we can do. So these two formulas are going to be our helpful thing to work with today. So let's head back over and take a look at a problem involving this. So does the age at which a child begins to talk predict a later score on a test of mental ability? A study of development of young children recorded the age and months at which the 21 children first spoke their first words and their Gessel, I should have looked this up before this, adaptive score, the result of an aptitude test taken much later. So first off, let's do a quick reminder of ourselves about which one of these things do we want to call X and call Y. Remember that X is typically, and we always in this class have discussed this as the explanatory variable, while our Y is the response variable. So in this case, we want to think about what should we call X, and thus by default what becomes the Y, and why does that make sense? Well, we want to think about it as the explanatory variable. Which variable from above here explains the other one, explains the response we might see in the other one. So for example, age would explain sort of shoe size as a way to sort of think about things. So here, why don't you pause the video and think about which one would be the explanatory variable and why? So I ended up saying here that age should be our explanatory variable, our X variable, because we think that that age of the first word being spoken is the thing that might explain sort of their score on this aptitude test later in life. So because of that, I can now sort of label the stats that we have here down below. So on the left, we have some X stats, X bar and S sub X. So we now know that is associated with the age of the first word spoken. And then the Y bar and S sub Y is on the right side. We know that that is the Gessel adaptive score. I'll call it GAS for short. And then the R value is the correlation between those, which was incorrect. It should have had a negative 0.6403. If your teacher didn't tell you that, then make sure that you go ahead and do that really quickly and fix that. And that should make sense because we're sort of thinking that it is a negative correlation, that the longer it takes you to say your first word means that maybe these aptitude tests later in life might not be as high as scores there. So now let's go ahead and get into doing our calculations here. So we're going to find the value of B first. We can't ever actually find the value of A in our equation, the intercept first. It's always going to have to be the slope first, and we'll see why in just a moment. So to find the value of B, we're going to go ahead and use that formula from above. So S sub Y over S sub X. And we're going to plug in the values that we have right here, which is negative 0.6403 times, and then we have 13.99 over 7.95. Go ahead and grab your calculator and calculate that really quickly if you need to. And what you should have found is that you get about 1.1267. We'll go ahead and round that up to 13. We'll just go to 2 decimal places here. Great. So now we have to represent what this means in context. Negative. Negative. I keep dropping my negatives. So now we need to go ahead and interpret this in context. This is the slope. B is our slope here. So what you're trying to think of is like, what does the slope mean for this regression model here in context? Why don't you take a moment and think about it, even maybe write it down, and then watch what I come up with. So here's what I came up with. For each additional month it takes for a baby to speak their first word, it is predicted their GAS will decrease by 1.13 points. So you see I have there, sort of turned this slope of negative 1.13 into like 1.13 over 1. And then it's talking about points over the months. That's our Y's and X's and their units involving those things. And so I talk about 1 month increase results in a point decrease of about 1.13. And I'm throwing in that word predicted because remember, it's not a guarantee that that happens, okay? We have the real data in front of us. If somebody spoke first at 12 months and then 13 months, we would not see that on the GAS that they have literally a 1.3 point difference there. Instead, it's just what the model predicts it would be, okay? So we have to make sure we use that word predicted in all of this. All right, so let's go ahead and move on down to C now. C, we're going to go ahead and find the value of A. Well, now that we have B, that's going to help us out because the formula involving A is this one here. We got Y bar equals A plus B times X bar. And before finding B, we would have not been able to do anything with this formula, but now we can here. So let's go ahead and plug in the things that we have here. We have that the Y bar is 93.67. We don't know A, and that's what we're going to solve for. We just found that the B value is negative 1.13, so we'll toss that in. And our info up above says that our X bar is 14.38. So go ahead and take a moment and solve for the value of A here, and then check in with what I come up with. So here is my work here. So I multiplied out those two factors on the right side and then added it over the 16.2494, got 109.92 approximately for our A value. So now it's time to interpret what that means in context. Take a moment to think about that and write it down, or just think about it and wait for my result. So here's what I came up with. A baby who first speaks at 0 months is predicted, once again, using that word predicted, to get a GAS of 109.92 points. I guess I should clarify on this one here. Later in life. I probably am not giving a newborn baby an aptitude test. I think the baby probably won't do very well on it. Also, this is a nonsensical idea. Like, there's no baby who just comes straight out of the womb and is like, hey, what's up? How's it going? Can I get some ice cream? So obviously this is a prediction that is a bit of an extrapolation, okay? Remember, extrapolations are very dangerous when it comes to trying to predict. All right, so let's go ahead and get down into this. We're going to find the linear model for this association. So we're going to take all of this information we just found and write out our equation. If you don't remember, you can just go ahead and jump right to it. But if you want to pause the video real quick to see if you can come up with it yourself, great. Otherwise, here I go. It's going to be, we're going to call it score, but with a hat on it. Remember, because it's a prediction here. We're not actually saying that this is for sure the score. This is a predicted score. The score on this test is going to be equal to 109.92 minus 1.13 times months. We'll go with months as it's, or age. Doesn't really matter what sort of, I think I like actually age better. Now that I said it out loud, I like age better. We're going to go with that. You don't have to get too specific with this. Remember, we don't use Y and X. We actually sort of use the actual variable names in all of it. All right. And then so now go ahead, and I believe that you can do E all by yourself. I am not going to go over it, but that is for you to go ahead and pause the video and try on your own. All right, so now we're on to the backside here. And another common thing that happens with regard to sort of coming up with linear models is you might get some computer outputs, okay? So what's happened is the data has been entered into a computer, it does its thing, and then it spits out sort of a summary of all the statistics. And Some of the stuff in there is going to be very important to us. Some of the stuff is going to be complete nonsense or things we never actually deal with. And so we have to sort of make sense of it all and be aware of like what's the important information in here and what do we just get to ignore. And maybe some of the stuff actually we ignore now and might come back to it a bit later. So let's take a look at our first one. So the longer you play a video game, the higher the score you can usually achieve. An analysis of a popular game found the following association between the number of hours a player has played the game and their corresponding high score on that game. So you can see over here, here's our box. It's got for us dependent variable is high score. Notice they use the word dependent variable, and that's not usually a word we use in statistics. What we would use there instead is that we would talk about that being the response variable. So usually the independent variable and dependent variable is your X and your Y respectively in maybe a math class like algebra. In stats though, we would actually say instead explanatory for X and response for Y. And so in this case, high score is the response variable. That's our Y value. So that'll actually help us out right away with our writing our linear model here, because we're going to write that the Y value is going to be high score. So we would go pen just died on me there. Whoa. Let's try that again. So high score with a hat on it. Boop, boop. All right, let's keep going over here. So R squared, hey, gives us the R squared value there as a percentage. That's nice. So if we ever were asked sort of to think about what percent of the variability can be explained by our model here, then we have actually that percentage. We got S with degrees of freedom. That's not something we ever have talked about here. Maybe we will later on in life, but that seems like that's information we don't need right now. And then we here have sort of like a little table here, variable, coefficient, and then standard error of coefficient. So it has the different variables. Constant. Constant, you'll notice from our words up here, is not actually the name of one of our variables. That is because it is literally the constant in this particular case, the A value. So the coefficient for that is going to be 524.8. That's our A value there. S, standard error of a coefficient, that's something that's not related to what we're doing here. So that's not very helpful information at all over there. And then we got plus, this is going to be our slope. Well, the other variable is hours. If we read through this again, you got high score, you got hours played. So the coefficient, which would be our slope in this case, is going to be 2,498.8 times hours. So in the end, the really only thing that we really paid attention to in here was just this right here. And this is a really common way of sort of framing it. It'll tell you what your different variables are. One of them will always be called constant, and the other variable will be your explanatory variable. And we also kind of use that top line, but we rethought of this as the response variable, not the dependent variable, but that's okay to use there. All right. At this point, I think you are set to fill out the rest of this backside. Okay, let me just walk you through it really quickly. So now it's going to ask you what's the intercept of the model. We've already found all those numbers up here in the box and wrote the equation for ourselves. So we're set up for that and ready to rock and roll. So interpret that in context. What's the slope? And interpret that. And then a little hint back at something called residuals. If you don't recall what a residual is, let me remind you really quickly. The residual for a point in a scatter plot is the actual Y value minus the predicted Y value. In this case, our Y values are high scores. So any residual we calculate would be the gamer's actual high score subtracted by what the model predicts for that. So this one's asking about, do you think a gamer would prefer to have a positive residual or a negative residual, and why does that make sense? Be sure to use that definition. And then Let's go ahead and scroll down a little bit more. Here's a slightly different computer output with a lot more information going on in there, but I think you can see within this table here just exactly what would be of importance to you. There's a lot of superfluous information in there. Some of it, again, maybe we'll actually use in the future, but for now, there's only a small portion of that table that's actually super helpful. So go ahead and take a look at it, try to dissect it, and fill out all of this. So I leave you to fill out the rest of this backside all by yourself and come into class ready to talk about and compare with some of your neighbors. We will see you in class.